All right, finally on the spring 2016 Math 213 final exam, they had an extra credit problem. You will too. It might not have anything to do with this. It might be very similar. I don't even remember what it is, to tell you the truth. What's going on is you have a small sphere inscribed inside a cube, which is inscribed in a larger sphere. This was one of the perfect problems we had, the beer sphere problem. How many times bigger is the volume of the large sphere than the volume of the small sphere? And then you're given some hints. So, oh, and yeah, this is the small sphere. Here's the big sphere, and I couldn't find one with all three in the same thing. And the little hints I give you the formula for the volume of a sphere, and I tell you that the answer is the same for any sphere. So you can make the small sphere whatever size you want. So one way you could do this is let's make this radius just equal to 1. If this radius is equal to 1, then the volume of the small sphere is 4/3 pi times the radius cubed, so times 1 cubed, which is just 4/3 pi or 4 pi over 3, however you want to write that. But I need to know the volume of the large sphere, so I have to figure out the radius of the large sphere, which is hard to do, but if I could just figure out that radius, then I could compare the two of those volumes and I'd be done. Well, the way I can figure that out is if this radius is 1, that means the distance from the midpoint out here is 1, and therefore any side length is exactly 2. So this is 2, therefore this is 2, this is 2, this is 2, those are all 2's. How does that help me? Well, the diameter of the big sphere is, see how well I can draw, 3 dimensions, sure. The diameter of the big sphere is the same as the length of the diagonal of the cube. So if I can figure out the length of the diagonal of the big cube, I'd have the diameter of the sphere, and I could cut that in half, and that would give me the radius of the sphere, and then I could use that to figure out everything I need. So how can I figure that out? Well, I have some Pythagorean theorem to apply. Maybe I first figure out this side length. I'll call this x. I have this right triangle here, and it is, let's draw it with the same orientation. This is 2, and this is 2, and this is x. So 2 squared plus 2 squared must be, plus 2 squared must be equal to x squared. So 4 plus 4 is x squared. In other words, x is the square root of 8. Okay, that's not my answer, but that's really helpful because now I have, it's going to be hard to see, this triangle that uses this side length, that x that I just figured out, this edge here, which I know to be equal to 2, and then this diagonal here, which is what I was hoping to figure out. Maybe I call that y. So I can apply Pythagorean theorem again because this is a right angle. So one of its side lengths, which is x squared, plus another side length, which is a side length of the cube and therefore has length 2, that's got to be equal to y squared. And I just figured out a minute ago that x was the square root of 8, so the square root of 8 squared plus 2 squared must be equal to y squared. So 8 plus 4 is y squared, so y is equal to the square root of 12. Y is the circumference, so the radius is equal to half of that, the square root of 12 over 2. So if I have the radius, I can figure out the volume of the big sphere because it is 4/3 pi times the radius, so that's the square root of 12 over 2 cubed. And what I'm asked is how many times bigger is the volume of the large sphere than the volume of the small? Hopefully, yeah, small sphere. What's this number divided by this number? Well, it looks really bad. 4/3 pi times the square root of 12 over 2 cubed divided by this, which is 4/3 pi. But a nice thing happens. This cancels out with this, so that I'm left with this. Oops, this is cubed up here. I'm left with just the square root of 12 divided by 2 cubed. And this is a perfectly good answer. There's different ways that you can write this answer. Maybe it turns out, and I don't know if you know this or not, and I don't really care one way or another, that this is 2 times the square root of 3. The square root of 12 is the square root of 4 times the square root of 3, but the square root of 4 is just 2. So I can say that's 2 root 3 divided by 2, but the 2 root 3 is cubed. So I can take that cube and I can cube both of these guys, and that gives me 8 times, I don't know, the square root of 27, maybe, divided by 2, because I'm not cubing the bottom. And this 8 and this 2 can cancel each other out, and it can give me 4 times the square root of 27. But the square root of 27 is the square root of 9 times the square root of 3. So I can say this is 4 times 3 root 3, or this is equal to 12 root 3. But that was just kind of amusing myself. I think most people would have stopped right here. Any of these are totally fine. I think some of you could follow that algebra, but a lot of you probably couldn't, and you'd stop right here, and that's totally fine. And if you couldn't get there, it doesn't matter, because this was an extra credit problem to begin with.